He could see a machine running perfectly in his head long before metal ever met fire. He could hear the future of electricity like a chord, hold it in his mind, and then turn that sound into coils, wires, and blue-white sparks. That man was Nikola Tesla, the inventor who helped convert silent, invisible forces into the humming, wired world we live in today. This is the story of how imagination met engineering, how a single idea reshaped cities, and how brilliance can be brilliant and brittle at the same time. Tesla was born in 1856 in a mountain village that now sits in modern-day Croatia. His father was an Orthodox priest who trusted faith and discipline. His mother, with little formal schooling, made clever household tools and worked with her hands. From them he carried two founding impulses, a reverence for ideas and a tactile instinct for how things fit together. Those impulses turned into a habit that followed him his whole life. He didn't always sketch or build first. He built entire machines inside his head and tested them there until every part sang in place. He described inventions as coming fully formed, like visions. Later engineers would call this a mix of extreme visualization and relentless iteration. As a young engineer in Europe, Tesla worked in telegraphy and electrical shops. He observed how electricity behaved and how people thought about it. By the time he arrived in New York in 1884, he had a head full of designs and a single letter of introduction. The city he landed in was already wired for a practical system, direct current, or DC, championed by Thomas Edison. DC was straightforward. It worked well for lighting neighborhoods from local generators, but there were limits. DC didn't travel far without massive loss. Each neighborhood needed its own plant to feed its lamps and motors. Tesla's insight was to think in waves and phases, alternating current. AC could change voltage with transformers, raise the voltage, send the power long distances at low current, then step it down near the user. One plant could light a whole city. More than elegance, AC unlocked scale. But the idea threatened the fortunes invested in the existing system. Money and reputation were on the line, and that is where engineering meets politics and theater. The clash that followed became known as the War of Currents. Edison, with an instinct for showmanship and sales, staged demonstrations to make AC appear dangerous. He electrocuted animals, published pamphlets, and painted AC as a public menace, all to protect DC businesses. Tesla, by contrast, trusted equations and experiments. He refined polyphase AC generators and motors that could be scaled and linked together. George Westinghouse, a businessman and engineer, saw the promise and licensed Tesla's patents. Together they pushed AC into real systems. The turning point was a physical public one, Niagara Falls. In 1896, an AC-driven plant harnessed the falls and began sending power to Buffalo. For the first time, electricity was traveling miles and lighting factories and streets from one remote source. It was a practical demonstration that rewrote what was possible. Long-distance transmission, interconnected grids, industrial electrification. The light that turns on when you flip a switch traces its ancestry to this proof by example. Tesla's work didn't stop at making power flow. He chased the edges, the high frequencies and high voltages where current behaves like light and lightning. He invented and popularized the Tesla coil, a resonant transformer that makes spectacular arcs and glowing corona effects. The coil is showy, yes, but it also taught engineers how to handle resonance, inductance, and the strange behavior of electricity when pushed into extremes. Tesla used those lessons in experiments with early X-rays, with neon and phosphorescent lighting, and with demonstrations that looked like magic, lights glowing without wires, glass bulbs humming with invisible fields, beads of plasma dancing on the ends of metal rods. One public moment captures how Tesla put wonder and utility together. In 1898, at Madison Square Garden, he unveiled a radio-controlled boat. He sent a small craft across a pond and steered it using radio signals, a spectacle that made people clap and ask whether a magician was at work. That small demonstration planted the seed of remote control and robotics. Teleoperators would later pilot submarines, drones, and satellites, all in some part descendants of that green boat on a pond. Tesla's ambitions grew larger. He imagined a global wireless system, a network that could carry messages, and he claimed even power, through the earth and the air. He began building Wardenclyffe Tower on Long Island, a tall structure intended to be a hub for worldwide wireless transmission. Investors came and went. J.P. Morgan provided some backing, but as the plan grew from a commercial signal station into a universal transmitter that promised free signals and maybe free power, funding dried up. The tower never fulfilled Tesla's grander dreams. To the world it became a symbol, the high cost of ideas when they outpace financial backing, and the way invention without a sustainable business model, risks turning genius into ruins. Business reality shadowed Tesla more than technical limits did. He held patents and sought recognition, but he often resisted the kind of tight, profit-driven arrangements that build long-lived companies. He made trade-offs at one point. He struck a deal with Westinghouse that could have made him rich through royalties, and then he agreed to forego the royalties when Westinghouse's company struggled. That choice kept AC's champion afloat, but it shortened Tesla's own financial runway. Credit and crediting were messy. Debates over who invented what, radio in particular, entangled Tesla, Guglielmo Marconi, and many others. In 1943, months after Tesla's death, the U.S. Supreme Court ruled in a case that restored some of Tesla's radio patents, acknowledging that his earlier work had paved crucial ground. Recognition sometimes came late, and money often didn't come at all. There are human details in Tesla's story that are easy to gloss over but important to feel. He was not only an inventor, he was an eccentric whose life orbited his work. He kept late hours. He lived in New York hotels when his fortunes dwindled. He fed pigeons in city parks and formed routines that comforted him when institutional support evaporated. He died in 1943 alone in a hotel room with notebooks and patents filling trunks and drawers. After his death, the world had the machines and systems he'd helped design. The man who'd once seen them complete in his mind had been reduced to a character in museums and biographies. Yet in retrospect, the arc of his life looks less like a simple tragedy and more like a complicated lesson. First, genius is not just flashes of insight. It's imagination plus discipline, the ability to iterate, to test, and to endure failure. Tesla's mind supplied dramatic flashes, but he also spent years refining coils, motors, and generators until they worked in the messy real world. Second, technology is as social as it is scientific. Markets, investors, and personalities decide what becomes infrastructure and what becomes an oddity. Tesla's ideas were brilliant, but success required allies who could translate patents into factories and consumers into customers. Third, ambition without a durable business plan can make a visionary tragic, as often as it makes one heroic. Tesla gave away opportunities and stubbornly pursued grander engineering visions. Those are morally complex choices. They're admirable in some ways and costly in others. The legacy is everywhere. The polyphase AC motors and transformers he refined are at the heart of grids that power homes, factories, and cities. The Tesla coil lives on as a teaching tool and a showpiece, a way to make electricity visible and thrilling. Radio and remote control grew from experiments he helped pioneer. Lighting technologies, early X-ray imaging, and even concepts in wireless transmission trace lines back to his notebooks. Engineers and inventors standing at workbenches today still reach for the same questions he chased. How do we transmit energy efficiently? How do we make invisible forces useful? How far can we push the physics before the system breaks? There is also a public cultural afterlife. Museums now display his coils and models. Popular culture has reclaimed him as the archetype of the brilliant eccentric, the icon of the misunderstood inventor. That story comforts us. The genius who cared more about the idea than the ledger, but it's worth resisting a single sentimental read. Tesla's life teaches us to admire imagination while also building the scaffolding around it. Legal protections, business plans, partnerships that turn insight into systems people can rely on. When you flip a switch, tune a radio, or watch a drone lift, you're seeing threads of Tesla's work. The next time a city's lights come on, think about the system of transformers and alternating currents that move power miles between generation and use. Think about the social bargains behind which technologies win and which ones fade. And remember that innovation needs two kinds of courage: the courage to imagine and the courage to make the idea live inside messy human institutions. If this story left you curious, subscribe to follow more profiles of the people who changed the modern world. Tell us in the comments which Tesla invention surprised you most. Check the description for books and museums if you want to dive deeper into his life and his labs. Thanks for listening, keep wondering, and keep building.